Good afternoon, dear colleagues. My name is Sergey. I'm from State Space Agency of Ukraine, representing the Ukrainian team here. We are very happy to see colleagues and friends from United Nations, European Commission, from UK, also, GEO Secretariat, and businesses and science. And having such kind of experienced experts in different areas means that the topic of our session is really actual. And it sounds leveraging Earth intelligence for post-conflict environmental recovery. As we know, there are numerous conflict zones in the world, and one of the most severe conflicts is underway in Ukraine. We are facing with numerous challenges, such as destroyed infrastructure and housing, mining of the territories, biodiversity loss, etc. And one of the biggest challenges is environmental impact of the conflict. Today, we are going to explore how Earth observation data and up-to-date technologies can be leveraged to address post-conflict environmental assessment, monitoring, and recovery efforts. We are also going to discuss the possibility to start pilot project in Ukraine devoted to environmental challenges, and the outcomes of such project could be relevant for other conflict zones. We hope for fruitful discussions today. We have actually three main sections today. It's introduction sections. We are here, and after that we have a set of presentations, and later on a section for discussions and questions. And following to the agenda, I would like to give floor to Madiha Baeva, Chief Work Program Coordinator, GEO Secretary, please.
Thank you very much, Sergey, and good afternoon, everyone. As many of you are aware, the GEO Work Program covers 6 thematic focus areas, ranging from food security and agriculture, to disaster resilience, to biodiversity and ecosystems, to One Health. But what it does not contain, not a single activity out of our total 49 programs, is a coordinated framework for assessing post-conflict environmental impacts. So this is the topic of this session. We know that we have the capacity to monitor and assess these impacts through this community. The Earth observation tools exist, and they're becoming more powerful, more accurate, more accessible. And what we now need to discuss is whether we need a coordinated GEO framework to turn that capacity into operational Earth intelligence for post-conflict environmental recovery, and what the key components of such a program or approach should be. So because I speak on behalf of the work program, just one point on scope. A GEO work program activity by design cannot be exclusively focused only on one country. However, it can start as a pilot focused on one country or one region, as long as it has a sight towards more broader applicability. So we want to see in the vision that there is the architecture, the methods, and the products are scalable. As you consider, Sergey and colleagues, a possible submission to the GEO work program, there are 4 elements to keep in mind. We want to see that there is a clear user demand and a clear user base for any new pilot. We want to see that there is a specific product or service that is being designed and piloted that could then get scaled. And then we want to see a partnership approach that brings together committed partners with their technical and financial capabilities to support that work. And finally, as I've already mentioned, a vision towards to making this program broader. Any activity that gets included within the GEO work program then gets support through our program board as it continues on its development journey through visibility, connections, and we really do encourage new submissions and new partners to come and add value to the work program. From our perspective, this session is the first co-design moment where we can really have this conversation. We were very pleased to see that you have allocated 30 minutes for an open discussion, and I hope that the participants will also engage. And if the interest and value of such a program is confirmed in today's session, then from our perspective, a natural next step would be a co-design workshop, which would then further elaborate on what the scope and specific aspects of such a work program activity could be. And I do really want to mention UNEP as an important partnership before I begin, before the session continues rather. UNEP has spent 2 decades building a methodology for post-conflict environmental assessments. They do have a lot of experience that we can then build on and add additional Earth observation insights. So Piercarlo, really looking forward to hearing what you're going to have to say. And then just to conclude, I think there are 3 important questions that we would love to answer at the end of this session. One is there a genuine demand for a GEO activity in the space? What the scope and partnership model of such an activity would look like, and who is ready to help build it with technical and financial resources? I understand we might not answer all of those questions immediately, but that is the vision, I suppose, and it's the first. Well, I've heard you've already had a couple of conversations, but in this GEO gathering, at least, it's the first conversation we're having. And the GEO Secretariat looks forward to supporting the process under the guidance of our program board. And with that, I turn it back to you, Sergey.
Many thanks, Malika, for introduction and for information you provided. Let's start our presentation. And the first speaker should have been Vladimir Mikheyev, the acting head of the State Space Agency of Ukraine, and head of the Ukrainian GEO office. But unfortunately, at the last moment, his business trip was cancelled by the government because of the governmental session and meeting devoted to conflict situation around the conflict, and I was authorized to present his presentation. And please go. Yeah, too quickly.
Very good presentation. It was
Good. At least quick.
very effective.
Very effective. Yeah, it's the content of the presentation. Yeah, we will briefly have a look at the world conflict, main challenges in terms of conflict in Ukraine, particular environmental impact and importance to understand that it's not only Ukrainian problem, but transboundary environmental impact, and let's say cooperation and possible steps, please. Yeah. Hey. Great. So thanks. Actually, yeah, the world faces a record level of conflicts and violence with serious impact to our life, and we have some UN information from United Nations, and particularly in 2023 there was around over than 170 armed conflicts, and by the end of this year around 120 million people worldwide were forcibly displaced, and one of the most important impact is environmental impact, and specifically it's It's a multi-sectoral impact, air, water, soil ecosystem, etc. Please, next. And as you mentioned, and today we have one of the most severe war conflict in Ukraine, and we are facing numerous challenges, and particularly assessment of destroyed infrastructure and housing using modern technologies, humanitarian demining of territories temporarily occupied, diagnostics of underground infrastructure, environmental impact of the war. Next one. And one of the most severe consequences or challenges is environmental impact in Ukraine, and particularly air pollution from fires, explosions, and industrial damage, water contamination due to infrastructure destruction, soil degradation, biodiversity loss and ecosystem fragmentation, and some other challenges. Next one. This slide was prepared with participation of our environmental experts. They are sitting here in our audience, and we will go in details during the section of discussion and questions. Next one, please. No, previous one. Yeah, very important actually. Slide also prepared together with experts is actually saying that it's not only Ukrainian problem, and because there is no border for air, water, etc., and other countries, other regions also facing such kind of challenges, particularly our neighboring countries like Poland, Slovakia, Hungary, and others. Next one, please. How to cope with these challenges? First line is a synergy through joint efforts, because as we mentioned, it's not only Ukrainian problem, it's a common problem, and we have to combine efforts together to define strategies, action plan, and coordinate actions and shared expertise here. And another important line is to use advanced technologies for environmental recovery, such as Earth observation data, including very high resolution imagery, combined with innovative analytics, artificial intelligence, machine learning, and provide powerful tools for post-conflict environmental assessment, continuous monitoring, and effective recovery planning. Next one, please. What is the first possible steps? Yes, as already mentioned, yes, we had a preliminary discussion. I'm going to have, and let's say one of the options is to launch a pilot project focused on post-conflict environmental recovery in Ukraine, in order to test technologies and demonstrate and to do appropriate demonstration of advanced space-based and analytical technologies for environmental assessment and restoration. And as a result and outcomes of this project could be potentially used in other conflict zones and regions. Next one. Oh, thank you very much. As we discussed in terms of, in order to follow the agenda and to keep in time, all questions and discussions will be held during our section. So today I would like to give the floor Pier Carlo Sandei from United Nations Environmental Program.
Thank you very much, and good afternoon, and thank you for the invite, and no expectations, no high rise. Okay, thank you very much. Now, I had the presentation, but I think I will leave it behind, and I will try to give you some considerations from the thinking we did in the last few hours also with the colleagues here. So as UNEP, we have been working for more than 20 years on post-conflict. And we started with the Balkans and then moved and did the assessment of post-conflict around the world in many, many situations. Now, we have seen a shift in the approach that we are having from post-conflict only to during the conflict. And this is the reason why I'm based in Kyiv since 3 years already now, when the war is still ongoing. And the question is why? Well, the main point is that, yes, it's important to have a post-conflict analysis, a comprehensive analysis of the impact of the war on the environment. But you also want to drive the green recovery of the country after the conflict. And if you don't collect this data during the conflict, and if you don't start having a policy dialogue which is based on data and science during the conflict, you will not be ready to influence the green recovery of the country. So this is why we started moving from a post-conflict only assessment to a during the conflict assessment. So this is why we did a preliminary assessment on Ukraine already in 2023. We did one on Gaza. We have a presence in Sudan today, in Somalia, in the Middle East. So we are not only going after the conflict, which was the initial approach of the work, but we are there during the conflict itself. There is, as Sergei has shown in one of the pictures, there is always a regional dimension of the conflicts, and it's not only on the neighboring country immediately. It's not only on Moldova or Slovakia. We have seen landmines on the beaches of Turkey because they get washed out, and then the natural flow of the Black Sea brings the movement naturally from, in this sense, from Ukraine down to the other countries. So you always have effects of conflicts that span beyond the border. And this is why you need to have a regional approach and not only a country approach. And this is why you need to be able to look bigger than just local with the local data collection that you can see. One of the main reasons is that green recovery needs to be built on data and science. It cannot be built on, I think, I heard, I read on Facebook. My mother always told me, for an Italian, the mother is important, but it's not the reason why how you should build your green recovery of a country. And you see, but this is why you need to build the recovery of a country on solid scientific data. And this is what, as UNEP, we try always to bring the data on the ground that are in reality, rather than debunking certain myths which are still there on the environmental component. How the situation has changed in the last few years since I moved to Kyiv? Well, we have much more access to the ground. I mean, when I moved to Kyiv 3 years ago, it was a completely different city and the country was completely different. And people were, let's say, much more concerned about movement around the country. Now, after so many years, I think we got used to the situation and we understood how to deal with it. So there is much more data collection that can happen on the ground. So satellite technologies and remote sensing were extremely useful at the beginning of the conflict, when there is this situation of lack of possibility of movement and ground truthing and data collection on the ground. Now, at least for a part of the country, we can go and collect data on the spot, and we can validate what we saw from the sky to what we see on the ground, and vice versa. Still, there is a big part of the country which is not accessible, which we need to be able to monitor, and which we need to have the country able to report to meet its international obligations also in the multilateral environmental agreements. So this is where we see a value on the satellite technologies also during the conflict, on being able to monitor the whole country, also in the parts that you cannot really access from the ground. And this is, as UNEP, we are also the host of many secretariats of multilateral environmental agreements. So we are keen in being able to have from Ukraine a number of data that are important for the global monitoring and the local monitoring of information. Now, we are seeing this now in the Middle East. We are preparing now a report on the Middle East war and with initial data, and it will be fully based on satellite technologies at the moment because, again, we don't have access there. So for us, going to the first question is, these kind of information are critical to be able to produce the environmental assessments that UNEP is famous for. I mean, we have based our information on satellite data for the past 20 years, and we will continue doing it. Of course, there is the need of having more access because sometimes it's limited because of the war. Sometimes it's released with delay. Sometimes certain things are not monitored. Sometimes certain things the country themselves don't want you to look at. So there is also the need of having some high political sensitivity on what you monitor and when and how. But this is something that we will need to do even more. So the reason why we are here is that we are fully committed and interested in the process. As I said, the branch we are working in is working globally. So starting from Ukraine beyond and learning from Ukraine for other similar cases. This is something that I think is something that we have been doing throughout. But exactly, maybe the idea is not only to focus on the post-conflict, but to focus also on the green recovery of the countries, where you need data, where you need to prepare for that, where you need to start preparing the legislative process, where you need to start preparing the economic situation, where you need to start preparing the labor market. I mean, we have done an analysis recently. In Ukraine, we can create 2 million green jobs in 4 years. And if you want a green recovery, you need green people. Now, not aliens, green people in the sense that they are working on green jobs. And so we need to prepare that. Because if you wait for the post-recovery and for the post-war, it will be too late to influence the economic factor. It will be too late to embed environment in that. So this is why we need to do it during the conflict, and this is why the data from satellite, but beyond satellite, is crucial for us. Thank you.
Many thanks, Piercarlo, for a very interesting presentation. And our next speaker is Michelle Rickson from European Commission Copernicus Program. Please, Michelle.
Thank you very much, Sergey, and good afternoon, everyone. It's a great pleasure to be here, and thank you also, Pierre, for the nice introduction and segue into Earth observations and, by the way, in situ data, which are also very important. Yes. If we can move to the slides. By the way, in the title of my presentations, I removed transboundary on purpose because the next speaker, Vincent-Henri, will cover some of those aspects, so I will save some time here. Yes, it's coming. For those who are, yeah, you can go to the next slide. Thank you. Yeah, for those who are not familiar with Copernicus, let me maybe just start now first by saying that the cooperation between the EU and Ukraine is not new, and there are already a number of agreements. The latest one is just pending the ratification on the Ukraine side for Ukraine to be formally associated to Copernicus, and that will provide also Ukraine with access to a number of dedicated, authorized access to some of the most critical features of Copernicus, and also be part of the Copernicus governance through the User Forum and Copernicus Committee. So we are really looking forward to welcoming you, hopefully very soon, in the Copernicus family. Next slide.
In Verkhovna Rada for consideration and ratification. Hopefully.
Yes. So what is Copernicus? Maybe some of you are not familiar with it. So Copernicus is the Earth observations component of the EU space program. The backbone of Copernicus relies on a fleet or constellation of so-called Sentinel satellites. Those are owned by the EU and operated by ESA and EUMETSAT on behalf of the EU. They are complemented also by contributing missions, which are adding, in general, high resolution, and we have specific agreements with a number of institutional or commercial providers. We mentioned in situ data, which are also very important for us for satellite retrievals, but also to quality check the products that are being delivered by Copernicus, in particular through 6 Copernicus services dealing with atmosphere, ocean, land, climate change, security, and emergency. And we'll hear also about some of them by Vincent later on. Those are providing added value services, and so they are ingesting all that information coming from satellites and in situ data. Most of those are provided on a full, free, and open basis, except for some of the products that are more dedicated to emergency security. Next slide. So as I said, most of the products are just available for use and are available on some of the data platforms that we have, in particular the Copernicus Data Space Ecosystem and GEO, essentially for Sentinel data, but also for through some of the data stores that are being implemented across the different services that we have in Copernicus. Next slide. A bit more detail on the Copernicus contributing missions. We have essentially 2 streams there. One is the so-called rapid response test. This is accessible to authorized users, so you can actually task for those people or those institutions who are authorized to task those satellites or who have access to that service. They can task a satellite and request specific imagery. Usually that's done for emergency or security services or marine monitoring, for example. The second stream is more a systematic data collection, in particular to support the land monitoring or the marine monitoring service. Next. Here an example of the land monitoring service. It is supporting the ecosystem and biodiversity assessment and monitoring through a number of parameters such as turbidity, trophic state, surface reflectance, land cover, FAPAR, NDVI, or hotspot monitoring, for example, to monitor the Natura 2000 areas. You see here, of course, because Ukraine is not part yet of Copernicus, so this is not yet covered, but it could be in the future. Next. Another service, so the Copernicus Emergency Management Service, has a number of also features and products. So one of which is this FIS, so stands for Forest Fire Information System. And you see here a snapshot of forest fires in a specific time frame. You see obviously that some of these areas are under intense forest fires for different reasons. Of course, conflicts is one element that's triggering also wildfires. Next slide. Another feature of this emergency management service is the rapid mapping. This is again accessible to authorized users, especially those who are a part of the Union Civil Protection Mechanism. Those can activate the rapid mapping either for preparedness or for emergency response or for recovery. And this is, in essence, what we're discussing here today. Next. On the security service side of Copernicus, we have one entity, the SATCEN, located in Spain, who holds a large collection of imagery. They are providing also geointelligence support for the EU external action. So this is used, for example, to document damage on infrastructures or ecosystem or environmental crimes. And you see here, for example, the example of the Kakova Reservoir in Ukraine, just to illustrate the point here. Next slide. SATCEN, you see here the nominal output of geospatial intelligence and how this has grown over the last decade or so with a sudden surge, or let's say a significant increase from 2021. And again, this is also due to the contribution and involvement of SATCEN in providing support also to current conflicts. Next slide. It's also important to note that the European capacity is also, or the share of European capacity in supporting those is also growing over time. So we're not relying anymore so much as in the past on external inputs, non-EU assets, basically. So it's very important that we have also, that we become also, within the European family, more sovereign in what we can deliver. Next. I will speak here on behalf, well, or under control, I would say, of my DGRTD colleagues who are sitting in the room. I just wanted to flag a few examples here, because besides Copernicus, which is organized under the DG DEFIS, you have also Horizon Europe, which is a separate program. And they're also spearheading a number of initiatives, some of which are, and many of which actually are accessible now also to Ukraine, unless stated otherwise, of course. And I just have listed here just a few examples, illustrating the point that we try to facilitate the access of Ukraine to research infrastructures, to different tools and R&D on civil security for society, whether disaster, emergency, use of drones, search and rescue, and so forth. Cluster 4 is where we, as DG DEFIS, have a particular stake, because this is where we promote the research and innovation around space, whether technology or the use of Copernicus and so forth. Under Cluster 6, you have also elements around, let's say, more cross-cutting elements on land, ocean, and so forth. You have, for example, specific calls with the deadlines here on forest wildfires or soil contamination and so forth. Next. I wanted also to point out that back in 2024, we have published under the umbrella of the Knowledge Center on Earth Observations, which is kind of partnership between DG DEFIS, DGRC, and DGRTD. We have developed this strategic document to identify research priorities. We are now in the process of updating that document for the next MFF, so the next period of the financial period of the European Union, so from 2028 to 2034. Next. And we have conducted a series of meetings, and we're now starting the drafting of that document, and we will in fall sometime, probably around October, November, we will hold also a stakeholder consultation. So we also welcome inputs from the community, especially those directly involved in Earth observations or Earth intelligence, and how we can exploit what Copernicus can provide. Of course, the input of the Ukraine community is also particularly welcome, because again, Ukraine is associated to Horizon, and we of course hope that the association to Copernicus will also be confirmed soon. Next slide. And that was it. Thank you very much.
Thank you very much, Michel, for very helpful information. And in Ukraine is really getting huge support from European Commission. And it was, as it was mentioned, that now the agreement between European Commission and Ukraine to join Ukraine to European Space Program, particularly to Copernicus, is under ratification in Verkhovna Rada. And hopefully at the nearest time, we will get access to vast amount of data and services. Thank you. Thanks. I would like to give the floor to Vincent Henry Pevich from European Center for Middle Range Weather Forecast.
Thank you, Sergey, and thank you for giving me the opportunity to delve a little deeper into the offer that Mitch indicated, focusing on two areas that we manage at ECMWF on behalf of the European Commission in the context of Copernicus. One being the atmosphere composition, including air pollution, greenhouse gases, topics that were highlighted in your presentation, Sergey, and also climate. I will not present to you solutions. They don't exist yet. What I will present is data sets and toolbox opportunities to basically help with the assessment of the war, find the baseline, and give some handle for basing the green recovery that Pier Paolo you were mentioning. Next slide, please. So yes, I won't go deep into this slide, just to say that ECMWF is an interested entity for the European Commission, and we implement directly two of the services, which I will talk about today, the atmosphere and climate, and we also contribute a lot to the emergency service, particularly for the wildfires and the floods. Next slide. So let me dive through the first example of where Copernicus data could help. This is an animation of fairly recent days showing the concentration of fine particulate matter at the surface, PM2.5. So this is the pollutants, for instance, that WHO uses as a key indicator of what they call the global burden of diseases, because it's the pollutants that has most impact on human health. What we do in Copernicus is that we use satellite observations. Satellites don't measure PM2.5 at the surface because of the physics. What the satellites measure is the vertically integrated amount of aerosol. And we need lots of modeling to convert this information into ground-based values. So here you see this animation. It's available all across Europe, including Ukraine, as you can see, at a resolution of 10 kilometers, which is quite good resolution regarding air pollution. We are not talking of the same resolution, of course, as land surfaces, and this can constitute a very good basis to basically estimate the exposure of the Ukrainian population to air pollution. What's key in Copernicus is the evaluation of the data sets. And there, I think it's a part of the work that will be very interesting to conduct with a Ukrainian colleague, bringing in situ observation, not only on for ground truthing, but also for helping to assess the delta between what would have been the situation outside of a conflict and what has been observed. You can also see that air pollution sees no boundary, so you see flows in and out of Ukraine, and this is the point that Sergei was mentioning, that these pollutants don't know frontiers. Next slide. The second example I would like to take, it was mentioned an estimation by colleagues in Ukraine about the emissions of greenhouse gases, in particular CO2. And there are certain sources where we have very good data from Copernicus, basing on satellite observation. And this is the example of wildfires. So these wildfires start naturally. They also start for reasons that people just light fires everywhere in the world, and some are triggered by the conflict. So this is the time series of emissions that we get. This is an average over a large portion of Eastern Europe, but we have this information at 10 kilometer by 10 kilometer information, meaning that at least for the CO2 emissions from active fires, we can have a very good handle on what has been the situation before the conflict, and during the conflict, and see after the conflict. The difficulty there is also that the natural variability from one year to another and the natural and non-natural elements are very difficult to disentangle. And so we have to take all these, air quality or emission from fires, in the context of a changing atmosphere. As you know, climate change is not a vague concept. It's happening fast. And the strength of the data that is available through Copernicus is to help disentangle these contributions. Next slide. So this is my final slide on atmosphere to show that actually it's possible to bring together these space-based or data set obtained through modeling using space-based observation with in situ observations. One of our users, a prominent user, Windy, which is a company that brings some of the Copernicus data to the general public, they managed to access some air quality observation in situ in Ukraine, and you can see some overlay of these. What I've plotted also is some example of sites in Poland and Romania, which are very, very close to the border of Ukraine, and showing that our space-based information is generally of quite high value. So adding a few more sites, etc., getting more confidence, then we'll have a good handle, I think, to base the estimate of the health or the pollution-induced health effects. Let me move now to climate and climate change. Next slide. I will start by one thing, because it was a major feature in 2025, which is a drier than average situation across most of Europe, with strong variation, but mostly over North and Eastern Europe. It was much drier, and one of the 3 driest years for soil moisture since 1992. And what is plotted here in terms of river flows is the fact that the river flow was below average in 70% of the rivers. And if you zoom over Ukraine, you see that in Ukraine, actually, it's many of the rivers were really low. Next slide. So there, in order to assess the situation and to use it for recovery, what's important is to bring together a large number of data sets. And this access to data set has been, I think, a limiting factor in the analysis that can be made of the natural climate change, or the climate change that is occurring outside of conflict, and any additional features that are on top of that. And this is exactly what the C3S Atlas is doing. You have the address there. And it gives a very easy handle to compare a lot of data sets about the past. I was in the town hall panel this morning and mentioned the ERA 5 reanalysis. So what has happened in the last 80 years, and put that also in context of climate projection of CEMIP and Cordex, which are done for the IPCC reporting. So it allows very easily, without having to download any data or without having to manipulate the data, some quick answers to many very important questions. So that's very interesting for science, for developing policy. But we can go one step further, and that's my last slide. It's something that we have been developing with a different purpose. Next slide. Which was to help the European Investment Bank to assess the validity and the usefulness of their investment. So there, what we have done is crossing the climate information, which is underpinning, with different activity sectors and the vulnerability or the aspect connected to this sector. So you can this application is in demo mode for the moment. So this is the one for the European Investment Bank. You select activity sector. You select what is the lifespan of the investment that you foresee, the locations or the geographical area of that, and you get a lot of information about this possible investment. So this is a tool that we think, through a very simple adaptation, we could repurpose for the objective of supporting Ukraine and helping with not only, yes, the post-war assessment, but really the recovery and looking at the long-term benefit of certain investment as opposed to other. And it's a good time really to ask this question, because at some point it's too late and the choices that have been made, not so well informed, could be detrimental. So a lot of opportunities, no solution yet, but I very much hope that very rapidly we'll be able to go and action all these observations with the Ukrainian colleagues.
Many thanks, Henry, in particular sense for support Ukraine many thanks, Vincent Henry, for your presentation, particularly for your support, because we started working with Vincent Henry teams in order to bring CAMS and C3S services for the benefit of Ukraine. Thank you. And our next speaker is a business representative, Hans Burman from Terramira company. Please, Hans.
Yes, thank you, Sergey, and thank you for being here representing the industry. I do have some solutions, by the way.
We said that differently.
So I'm from the Netherlands, and I'm working for a private company with about 100 Earth observation specialists. So maybe we can go to the first slide. Yeah, we go. Next one, please. Yep. So when we talk about how can we help from Earth observation support perspective, especially in conflict zones, we start with identifying the impacted areas at scale, as already mentioned by Piercarlo. Right, that's the first thing to do. We can do that obviously with multiple sources of remote sensing data, as you see in the picture, and derived time series. That's very important as well. It tells you something about historical perspectives. And next to that, for next step is then to let's keep the slide on. Next is to prioritize. And we do that with a risk-based model, which I come back to later, but it's basically providing you the overview of your total impact. And let's say damaged areas always have certain risks in them, low risk and high risk. So by prioritizing them, you see the total picture. With all that information and intelligence, you can build your plans, overall plan, but also individual plans for recovering electricity infrastructures, gas pipelines, houses, roads, or you can think of harbors, but also agriculture, water installations, and nature, obviously. With the help of AI, we can also do some environmental simulation modeling to see what impacts could be after some restrictions. And last but not least, we can help with monitoring the restoration process itself and report on it as well, which provides information at all levels within the government organizations. Next slide, please. Yeah, the next. Yeah, click again. Yeah, right. So the example was already mentioned, the Kokovka Dam in Ukraine. The top two pictures show the pre-damaged area, as where you can see from February 22 and October 22. In October 22, you see already some red dots, which is basically seasonal effects on the map. And then the impact of the damage was in, I believe, June 23. So in September, you see the huge impact on the environment here in the areas. And especially a year later, in 24, you see it's slightly recovering, but it's still very dry. So it's and it's already mentioned next to the level of dryness at the riverbanks, you also see water pollution, and drinking water is jeopardized a lot, but also irrigation water disappeared completely. Well, as a matter of fact, at this moment of time, I think Ukraine will come to a point where they have to make up a decision whether to rebuild the dam completely, or I think maybe a smaller dam, or even do nothing and leave it as it is. In all various scenarios, we can build scenarios and as I mentioned already before, environmental impacts simulations based on previous impact and AI models. We can definitely help the decision makers to decide on what's best step forward. Next slide, please. But in every, let's say, conflict zone, let's say safety first, right? So we this is not a real product yet. It's in the innovation program we're running to identify minefields with long wavelength SAR technology. We are able to see objects up to 25 centimeters in under the ground under dry conditions so far. So with this new technology, you should be capable of identifying minefields, and therefore you can clear them before entering and access the area. Next, please. So when we look at some examples, in this case for the infrastructure, I come back to my earlier point where I mentioned the risk-based model, which is the pyramid on the picture. So first step here is to scan with the satellite data initial inventory of the damage. That's the first step you do. And for example, the electricity pylon is one of those obvious damaged areas with low impact at this case. But in some cases you think, well, maybe we need more and additional information, and you start an additional inspection. So not necessarily with satellite data, but with other remote sensor data on the ground, as mentioned as well. So the road example might be one of them here. Is this just one, how you call it, sinkhole in one road, or are there more in this particular area or road, which makes it significant to have additional data to prioritize? And in some cases, you need direct interventions. So in this picture with the bridge, there's a crack in the bridge. Maybe you don't see it when you're on the bridge, but it might raise the question whether every truck and lorry can still pass this bridge, and therefore probably will need special attention, people going there and do some measurements. Well, by utilizing this kind of risk-based models, we can definitely help with determining the impact and determine priorities, especially in large-scale damaged areas. Next slide, please. Another example is about agriculture. We have an integrated administration and control system for monitoring agribusiness as a total, as a whole. But what it provides is actual information on soil and crop condition, for example. But also it makes records of progress of the crop and changes made by farmers. And this all provides a audit report, an approved audit report, which is really helpful for subsidized programs, right? So it can help by proving the money well spent in this kind of programs. So for subsidized budget control, it's really a step forward. Then the next one, which is about water availability. Again, understanding what the water condition is in certain areas definitely helps with defining the crop type. We have broad expertise in crop yields, irrigation, water methods, and we have models which predict the actual needs and also forecast based on seasonalities, based on rainfall analysis and weather forecasts, obviously. But again, with modern IE and long language models, we can make simulations to understand what's possible and what's impossible in certain areas. So before you decide what kind of crop you want to create, a deep analysis on the water availability is, I think, crucial. Well, those were just some example we do already on a global basis, and definitely can be of help in, I think, conflict zones, post, but also during, to be honest. Thank you.
Many thanks, Hans, for your information. Actually, we are happy to see you here in our session as a representative of innovative businesses, because for us it's really important to have modern, up-to-date technologies, particularly to cope with environmental impact of the conflict. Thanks again. Now we have to move to the panel part of the discussions, and one of the most important points to clarify is particularly is if the environmental impact of the conflict in Ukraine are also actual for other region countries and conflicts, and some speakers already share their vision to this, but also important point to get feedback from, particularly from environmental experts. And I would like to give a floor to Marina Gorobey. Could you introduce yourself, please? Our environmental expert in the area.
Yes, hello everyone. My name is Marina Gorobey. I'm PhD and I represent Institute of Ecological Renovation and Development of Ukraine. I'm very happy to be here today, and I would like to say big thanks to all speakers for this valuable impact and highlighting such important topics for Ukraine, and not only for Ukraine, because I would like to highlight it again that the main challenge from an environmental point of view is that the war creates the highly interconnected and long-term impacts affecting air quality, water systems, soils, biodiversity, ecosystems, and public health as well. And polluted air or water doesn't know the political borders, so it's not only the problem of Ukraine. And I would like to highlight that long-term impacts, they continue evolving. And we shouldn't wait until the war will finish to start recovery, because early assessment is critically important because many environmental processes, including contamination, migration, ecosystem degradation, and hydrological destruction, they begin immediately and may intensify over the time, and if not monitored, it could be consequences of higher disasters. So, and also I would like to say that one important aspect is that Earth observation could also be integrated with historical records of bombardments, military activities, industrial damage, and other conflict events in order to better understand environmental impacts and cumulative risks. And maybe at this point, one of key scientific challenge is integration of these fragmented environmental observations and Earth observations into some kind of operational recovery intelligence frameworks. So for this, I think Earth observation is critically important because many affected territories are inaccessible, dangerous, too large to rapid field assessment alone. And I think Ukraine could also serve as a pilot environment for developing scalable post-conflict environmental monitoring methodologies, which could be applicable in other conflict affected regions globally. Thank you very much.
Thank you, Marina, for your feedback. We also, one of the topics also is to discussing all different tools that could be used to support this topic. And I noticed that in the audience there is a Franz Imbler, probably from DG RTD. Probably, Franz, could you give a couple words from your side in terms of let's say RTD support, potential RTD support of this topic? Any ideas? Or? Yeah, if not, no problem.
Thanks for giving the floor. Of course, I cannot now commit to identify some sources of funding, but Mitch has actually shown a slide. There are some opportunities in the Horizon program, and there are some projects ongoing, which is very positive. Currently, we are actually preparing the next multi-annual financial framework, as you all know, with the European Competitiveness Fund and Horizon Europe as a self-standing program, but connected to this. This is all very much in the discussion, how this all then spells out and where happens what and who does what is still open. So it's also from that perspective, it's very difficult to tell where we can support you or with what means we can support you. But I can assure you that first of all, thanks to all the speakers, and it's very interesting what's already happening, and it's amazing what you guys are able to do in these very difficult situations. At least I can assure you that we will try our best to support you with the means that we may have at hand.
For your positive feedback. Okay, I would like to give a floor to Natalia Kusuli, a prominent Ukrainian science.
Yeah, I'm Natalia Kusul. I'm a professor from Kyiv Polytechnical University, University of Maryland, and I am GEO Principal Alternate Ukraine. So thank you very much for this great support of Ukraine, of this scientific and practical, very important topic of the recovery. I can say that Ukrainian scientists, in close cooperation with international scientists and researchers, do a lot already to estimate the impact of the war, environmental consequences of the war. And speaking about funding, we already have, and Ukrainian scientists already are participating in several Horizon Europe projects regarding forest monitorings. For example, one of the projects, SWIFT, is finished, has been finished right now. Another one is continuing, and within this project, Future 4, we are going to implement the European services of forest monitoring in Ukraine to extend the coverage of Copernicus services to Ukraine. Also, right now, we submitted our proposal to the call of European Space Agency, and it is about utilization of satellite data in governmental statistics. And one of the purposes is development of satellite-based indicators for agricultural statistics and for environmental statistics. So I hope we will be the winners of this tender, and we would be greatly grateful to collaborate with European partners who do these services for Europe, to do our best to implement them in Ukraine. And we, of course, from our side, will do our best to to look for funding, international funding, inside Ukraine funding, and helpful for international collaboration.
For many thanks, Natalia, for your intervention and for your feedback as a prominent Ukrainian scientist. And of course, what we are planning, it's definitely based on including your experience and knowledge. And thank you again. And colleagues, we are coming to an end here according to the timeline. Please, could you introduce yourself?
Sure. My name is Angelica Gutierrez. I'm the director of GeoClose, a flagship of GEO. And for those less familiar with GeoClose, it's a global hydrological forecasting built on ECMWF data. My question is, what governance and financing mechanisms are needed to ensure that this kind of forecasting and water intelligence systems are fully embedded on Ukraine's reconstruction decision-making, particularly for energy, for agriculture, transport, flood resilience, urban development, and emergency response? Thanks.
Okay, please.
If I can try to answer, because it's quite a challenging question, but if we take Kakhovka, which was mentioned before, the government decided that they will rebuild Kakhovka as it was where it was. To rebuild the dam, it will take 6 years. To refill the lake will take another 7 years. So this means that from the moment you can start the construction, you will have 13 years to wait before you can have the same services that the dam was providing before. Now the question is, do you really need a new old Kakhovka? Because Kakhovka was providing water for Crimea. Kakhovka was providing irrigation for the water for irrigation for the whole south of Ukraine. Now, is the Ukrainian irrigation system so efficient that you need that much water? Kakhovka was producing hydropower plant, so it was a hydropower plant. Now, do you really need to wait 13 years before you can produce the 9 megawatt that it was producing, or can you do it with solar in 6 months? Okay, maybe you want to use hydro as a battery for the solar, but maybe again, is it worth the investment? But then Kakhovka was also used for Zaporizhzhia nuclear power plant for its work. But the question is, will it be worth waiting 13 years for that? So when you ask for what kind of data, I think we need all the possible data to look at the wider picture. The government can connect the dots if they see the dots. You cannot connect dots that you don't see. So this is where we have the need of as many data as possible. So there's not a question on which data you need. We need all the possible data with the same time lapse, because if you look at data from 3 years ago and data from 2 years after, then you cannot compare apples with pears. And you need to have comparable data within the same time frame to be able to see what exactly you need for the next 50 years rather than what was there for the past 50 years. So the green recovery of the recovery needs all this data, every possible information, to be able to have a real full picture of what is the situation before you can decide on the future. And this is where it is very important to have multiple actors. And this is why you need a stakeholder consultation that allows everyone around the table to bring their point of view, to have a comparison of interest and the possible stakeholder views into a final complete decision rather than something taken in a closed door where you don't listen to anyone or you just listen to the last one who spoke. And that was the friend of the husband of the neighbor of somebody that you know, because this is how otherwise the connection are going. So this is where we need to break that circle. And this is why as UNEP, we are trying to provide this scientific information, bringing all the possible data. And this is why we are interested in expanding the data information gathering. And this is why we are here as well.
Many thanks, Piercarlo. The point is that we received a strong signal that we are coming to an end. And if you don't mind, I would like to just a kind of summarize to outline the key issues of that outcome of our discussion. I think, first of all, the discussions and speakers showed the importance or value of GEO community, because it's a great opportunity to get all main stakeholders, United Nations, European Commission, governments, businesses, and session in one place at appropriate time in order to get synergy and to combine efforts to cope with environmental impact of the conflicts. Another point is that environmental impact of the conflict is not only Ukrainian problems, and due to discussions we realize it's a common problems, even not even neighboring countries, but it's common problems. And the second point is the pilot project in Ukraine could be a starting point in order to develop, update, and check technologies that could be used in other conflict zones. And I would like to thank you very much for your time and efforts. And we are here today and tomorrow, and we could continue discussions in different formats. Thank you very much for your attention. Thank you.
Thank you.